I'm audible.
Yes,
Yes,
sir.
sir.
Is there any problem?
No,
No,
sir.
no,
No,
sir.
sir.
Okay. So this fundamental principles already you have seen. Number one is called as line of action of a force. The line on which a force acts is called as its line of action. Every force is having its own line of action. Number two, law of transmissibility of a force. The effect of a force on its line of action everywhere remains unchanged, constant to the geometry of the ball. This is technique of law of transmissibility. Many times what happens, there are several practical applications of law of transmissibility. In due course of time, we'll discuss all these practical applications. Don't worry at all. These are just starting points. At the start, it may be slightly difficult to understand, but how time passes, you will not find any difficulty. Okay, so that already was said. The most important part you have said that is called as the resolution of the force. Ours is a coplanar force system. In coplanar forces, there are two components. One is along x-axis, second one is along y-axis. The best example for that is you can consider a rectangular wall in front of you. Starting from bottom corner point, you can join one straight line to top opposite corner point that is called as a diagonal of the rectangle. For that diagonal, projected length along horizontal side is nothing but x component. Its projected length along y-axis is nothing but height of that rectangular wall. This horizontal side and vertical sides are nothing but x and y component. And these are the projections of the line along the x-axis or y-axis. These projections are denoted by letter x component and y component. Jyoti and Omkar, is there any problem?
No, sir, no
Jyoti
problem.
Pawar,
No problem, sir.
Jyoti,
No, sir, no problem.
ऐकू येतं ना व्यवस्थित?
हो, बरोबर, sir.
Can you listen me properly?
Yes, sir.
What about Omkar? Okay, okay, fine. So for every force, there are two components. One is along x-axis, second one is along y-axis. Second sketch, if you are looking, same sketch is given, not in rectangular form, but in triangular form. Okay, so this diagonal here is considered as the hypotenuse for triangle, and two sides of the triangle, one is horizontal, that is the base, and second one is the front side. There is fx and fy. Why it is required? It is required for resolution of the force, because rectangle triangle geometry you know. Cos theta equals to adjacent side divided by hypotenuse. Cos theta equals to adjacent side divided by hypotenuse. Adjacent side is what? Fx. So fx by f equals to cos theta. And hence adjacent side fx equals to cos of theta. It's so simple. Similarly, sin theta equals to front side divided by hypotenuse. It is sin theta equals to fy divided by f. So Fy equals to F sin theta. Fy equals to F sin theta. So you will get Fx and Fy. So Fx and Fy are the x and y component.
सर आवाज नहीं आ रही.
Was along
Hello.
x-axis and second one is along y-axis.
सर आवाज नहीं आ रही.
Then,
सर
if you
आवाज
consider
मध्ये
this
मध्ये
right angle
अडकतोय.
triangle, one is x component, second one is y component. So just from right angle triangle geometry, resultant you will get equals to square root of fx square plus fy square. And always x component is not to the right, it may be to the left. Always y component is not upward, it is downward also. So depending upon situation, x component may be to the right, maybe to the left, y component may be upward and maybe downward. Just one. Okay, so this case already you have seen yesterday also. Then, based on that, these are the sign conventions. If force is to the right plus left minus upward plus downward minus. This is called as sign conventions of the component forces. So if it is upward, call it is positive. If it is downward, call it is negative. Like that. Towards right plus left minus. Then yesterday you have seen this law of parallelogram of forces. If the two concurrent forces are represented in magnitude and direction by two adjacent sides of a parallelogram, then the diagonal of the parallelogram concurrent with the force represent their resultant. This is one of the famous law of parallelogram, and I think at 11, 12 already we have discussed this law of the parallelogram. So in this law of parallelogram, this diagonal OC is represented by length R. This is called as the resultant, and adjacent side OA and OBs are represented by its component forces P and Q. Angle between P and Q is denoted by letter alpha. Inclination of the resultant with its x component or with OA is theta. Then OB line is parallel to AC line. Magnitude-wise, OB and ACs are same, that is P, that is Q, sorry. Then CAD is considered as a right angle triangle. OB is parallel to AC, so inclination CAD, that is angle CAD, is nothing but again alpha. From this right angle triangle, cos alpha equals to AD divided by AC. AC means Q. So AD equals to Q cos of alpha. Sin alpha equals to CD divided by AC, and hence CD equals to Q sin alpha. And then finally what you have to do, OCD you have to consider as a right angle triangle, and by Pythagoras theorem simply you have to find out length of hypotenuse, and that length comes as R equals to square root of P square plus Q square plus 2PQ cos of alpha. And hence, whenever you are finding magnitude of the resultant, its direction is also very important. Direction is nothing but inclination of that resultant force with one of the component. And that component we have decided as force P. So, inclination of resultant with x-axis is theta. And that theta is again calculated by right angle triangle OCD. In this right angle triangle OCD, tangent of theta equals to front side divided by adjacent side. And hence, tan theta equals to CD divided by OD. OD is nothing but OA plus AD. So, with this CD, already you have seen that is Q sin of alpha. OD is nothing but OA plus AD. OA equals to P and AD equals to Q cos of alpha. And hence, you'll get idea related to our uh, magnitude of the resultant force. Okay, and this is called as a law of parallelogram. Nowadays, we are not using law of parallelogram. Reason for that is law of parallelogram is applicable only to find out resultant of two forces. By chance, if three or more than three forces are available, then what we have to do? Then this work becomes a very laborious work, or this work becomes very difficult. If n number of forces are available, then n times you have to use this law of parallelogram. So it's a very, very difficult and very laborious job. Nowadays, what you have to do, always you have to simplify the work. And when you have to simplify the work, this law of parallelogram becomes obsolete. And this parallelogram you can consider as a rectangle as a specific case. And in case of rectangle, x component and y components are nothing but adjacent sides and front sides of right angle triangle. So whatever right angle triangle geometry or rectangular geometry just now you have seen, for example, this rectangular geometry. This rectangular geometry is nothing but one particular case of law of parallelogram, and hence it is concluded that our regular resolution of the course is nothing but the part of law of a parallelogram only. So please be specific about this. This is one of the basic fundamental law for our discussion. Okay, now next. Force is a vector quantity. It has magnitude as well as direction. Like this force, there is one more very important parameter for our discussion, which is also a vector quantity, and that is moment. Moment of your force. There are two very synonymous terms: moment of a force and couple of forces. Moment of a force and couple of forces. Just like you are doing B course, some students are doing BTech course. Very similar, but still basic differences are available. So you are getting degree as B, and your some of the friends they are getting degree as BTech. Okay, so very much similarity is available. With that similarity, also some differences are available. Like this, in moment of a course and couple of courses, lot many similarities are available, and along with similarity, some differences are also. What differences are available? That we'll discuss. Okay, then first listen definition of moment. So is it audible to all? Division A student,
Yes, sir.
Yes.
Division B Jyoti,
Yes, sir.
Jyoti Pawar,
Yes, sir.
ऐकू येतं ना व्यवस्थित?
हो, sir.
Is there any problem?
No, sir.
Jyoti,
No, sir. No problem.
ऐकायला येतं ना व्यवस्थित?
हो.
Any student from Division B?
Yes, sir.
Division B students,
Yes, sir. Hello, sir.
can you listen me properly?
Yes,
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 sir.
sir.
Yes, sir.
Okay,
Yes, sir.
okay, fine.
Yes, sir.
Okay, moment of a force. Moment of a force is a vector quantity. It is, uh, hello, hello,
Yes.
what happened? Speak loudly. Okay. Just wait. That's why just now I have one. Okay, just now they have joined. All they have joined. Is it okay now? Okay. So there are two very important activities. One is called as moment of a force, and second one is called as couple of forces. Moment of a force is the product of force and the perpendicular distance between a line of action of a force and the point at which moment is taken. Once again, I will. Moment of a force is the product of force and the perpendicular distance between the line of action of a force and the point at which moment is taken. Please mute yourself. So, first sketch, if you are looking, point A is given, point B is also given. At point B, vertically downward force F is acting. Distance between A and B is D, that is your perpendicular distance. So, moment of F at point A is considered as F multiplied by T, F into T. F into T is the product of force and the perpendicular distance. Then, question arises. Force F is acting downward. Movement is what? Movement is the action. If you are opening the door and closing the door, that is a perfect example of movement. In case of movement, door doesn't get shift anywhere. It remains there itself. But it has two types of tendencies. Number one, to rotate in a clockwise direction or to rotate in anti-clockwise direction. These are the most possibilities. So force F is acting in both directions. If I am considering point A is a fixed point, then force F is pushing point B in downward direction. That is, distance AB rotates about point A in a clockwise direction. Clockwise direction. That is called as a clockwise move. Instead of this, if force F is acting in upward direction, then this rod AB may rotate in anti-clockwise direction. That is called as an anti-clockwise movement. So friends, there are two types of moment. Number one is clockwise moment, and number two is the anti-clockwise moment. Moment is the product of force and perpendicular distance. How in reality body rotates, either clockwise or maybe anti-clockwise. Accordingly, that moment is considered as clockwise moment or anti-clockwise moment. Moment is a vector. Whenever any individual force, individual moment you are considering, it is always positive. But in our numerical discussion, if some forces are acting in upward direction and some are acting in downward direction, then if you are considering upward positive, it is your duty to consider downward negative. Similarly, if some forces are acting to the right, some are acting to the left, then you have to use some sign convention. So, if I am considering towards right is positive, then definitely what I have to do, towards left I have to consider as negative. Hello? Is it visible?
Yes, sir. Yes.
Yes, sir.
Slide दिसते ना?
Yes, sir.
Yes,
It
sir.
is visible.
Then meanwhile I am going for this Gmeet because I have to admit this latecomers. Okay? ज्योती ऐकू येतं ना?
Yes, sir.
स्लाइड दिसते का?
Yes, sir. This day.
हॅलो ओंकार, ऐकायला येतं ना व्यवस्थित?
हो सर.
हा? कशामुळे? Just 1 minute. Just wait. Speaker. Speaker.
नाही स्पीकरचं काय करायचं हे
Hello. Now it's clear.
Yes, sir, it is clear.
Now what problem is coming? Because from my side there is no problem. Just wait.
जॉईन हो परत जॉईन हो लिहू ना परत जॉईन हो ठीक आहे लिहू परत जॉईन हो आता तो प्रॉब्लेम आहे
Hello, sir.
Hello.
Presentation is gone. Present.